All right, so last part. So again, before we continue our discussion, so anyone who has a question so far?
Sir, saan po ba makakabili ng breadboard?
Sa mga electronic shop. If you are here in Baguio, saan ka ba ngayon?
Baguio, sir.
Meron yan sa harap ng in front of SLU. The one that is ano ba? Hindi ko kasi alam yung pangalan ng store. But it has a motor shop, like second-hand motor shop, and then on the right side, we have a mini electronic shop in there. So most likely you will see a lot of buyers outside. So they are selling breadboards in there. And there is also one electronic shop in front or on the other side of Caltex, okay, of yung Bonifacio Highway also. Or in Mabini, there is also one in Mabini. So meron din doon. I just don't know the name, okay, of that store. So
Okay, sir. Thank you.
marami dyan. Electronic shop. Basta electronic shop. So any other concerns or questions so far? Okay, so I guess then. All right, so let us now finish this one. Okay, so let's talk about majority and minority triggers. So this one is very easy to understand. So when we say P-type, so we have more positive material in it, which is, whole. We call that one whole, okay, or button. Okay, so the majority of this one is whole, so the white one. And then the other one, which is the N-type, so it has more negative material, which is the electron. So majority of this one is the orange one, which is the electrons. So we call this one N-type, okay, or free electrons. Okay, so the next one is diode. Okay, so again, we have two parts for diode. We have the anode and then the cathode. So this is the symbol for the anode, and then this is the symbol for the cathode. So the entirety of that one is the diode. Okay, and in actual, okay, so if you're going to buy a diode, so we have this black one right here, like 80% of the this one is black, so that is the positive side or the p-type, and then the gray one is the cathode or the negative side of it. So most likely it's only it only has two parts, right? So the p-type and then the n-type. But in diode we have one more part, which is called the depletion region. Okay, so where can you find that depletion region? It's on the middle part of your p-type and then n-type. So again, when you see p region, that's where the hole can be found, and then n region, that is where electrons can be found. Okay, so let's talk about the more parts of the diode. So in here, as you guys can see, any kinds of a diode, okay, it could be germanium, silicon, gallium arsenide, boron. So you always have this kind of setup. We have the p-type, we have the n-type, and then the depletion region. All right. So in here, to make it simple, so the depletion region is where the hole and then the electron meets or mate with each other. I think mate is not the correct term. Parang yeah, because they're like mating, but yeah, they're like combining. Okay, so once they combine, they're gone. Then it's like forming the so-called electricity. Okay, because as we all know, we cannot have electricity if we don't have positive and negative. So just by combining positive and negative will result as an electricity. Okay, so the positive and ground. So this is the part where they meet and then form like an electricity. So the narrower, okay, the depletion region, the more electricity that will flow on this diode. And then the wider the depletion region, let's say this is how wide that depletion region, the more chance that the proton or the hole and then the electron will not meet with each other. So meaning it's resisting the flow of current. Okay, so depletion region, this region of uncovered positive and negative ions is called the depletion region due to the depletion of carriers. Okay, so dito sila, or this is where they are vanishing and then forming into a new energy or electricity. All right, so we have three possibilities for a diode. So we have the no bias. So no bias, meaning we didn't apply any voltage on it. So of course, if we're not going to apply any voltage, then nothing will happen. So as you guys can see, we have a current of 0, and then we have a 0 volt flow of voltage in here. Yeah, simple as that. And then we have this forward bias. So it's very, very straightforward when we say forward bias, meaning we are now applying voltage on this diode of ours. So our voltage now is above 0. So it could be 1 volt, 2 volts, 3 volts, 5 volts. Okay. So if we are going to apply this kind of setup, positive to positive, okay, positive to P type, and then negative to N type, this is the correct representation of forward bias. So if this is the kind of setup that you have, then it's like you're pressuring the P type and then N type to meet with each other. Okay, so means you are now like forcing them to create or to have the permission to flow of the electricity. Okay, so this one reduce the width of the depletion region. So it not only reduce, but it's like trying to banish. Okay, it's like not having a depletion region anymore. Okay, like completely P type and then N type is meeting with each other. Okay, and then the last one is the reverse bias. So we could say that this is quite similar with the no bias, since when I say reverse bias means we just have a opposite representation wherein a negative is connected to P type and then positive is connected to N type. And then in reverse bias, we also have zero current, since as we may all know, diode permits only, where is that one? Let's go back to diode. Okay, so this one only permits one direction. Okay, so if you have a different polarity, then it prevents the flow of electricity already. All right, so let's go back right here for the reverse bias. Okay, so in here, what's happening here is instead of pressure, it's like attracting the negative and positive to go right here. So it will cause the depletion region to widen. So once it happens, then uh, there is no permission of flow of electricity, because they are not meeting each other, or they are not combining with each other. Okay, so the same with this one, the positive and then N type. So most likely it's attracting to go on the right side. So yeah, it's also widening the depletion region. Okay, so here's a comparison about diodes. So MC forward bias, so positive to positive, negative to negative. So it has a flow of current. Okay, so our bulb is lighting up, or it's being lighted. And on the other way around, we have the reverse bias, which is negative to positive and then positive to negative. So again, this is similar with the no bias, because we have zero current on this part, because up to this point it's already not permitting the flow of current. So as a result, it wasn't able to light up this bulb right here. Okay, so did you guys get the idea so far on regarding the forward bias and then reverse bias? Hello, are you guys still around?
Yes, sir.
Okay, so let me ask Mr. Dayag, Mr. Carl Joshua Dayag.
Yes, sir.
Okay, great. So Mr. Dayag is here. Okay, great. So why use forward bias and reverse bias? So they have their own special usage, but most likely if you want to have a normal circuitry, then you have to use forward bias. So in some cases, we also use this one reverse bias. Okay. Then again, when see forward bias, it conducts current, and then reverse bias, it prohibits the current. Okay. But in actuality or in reality, okay, we have this one. So a very small amount of current can and thus go through a reverse bias diode. So we call that one the leakage current. Okay, especially if you have, let's say, 200 volts or 300 volts of voltage right here. So it will cause this diode to, not work as a diode anymore. It's like working as a wire because it's like you're forcing your voltage to flow in here. Okay, so it can only handle a certain amount of voltage, of course. Okay, so for the forward bias, of course, it works as the normal one. So again, a diode consumes an energy or consumes a voltage, or it eats a voltage, wherein if it's silicon, then it eats 0.7 volts. So let me just zoom this one in. So that is the reason why we have a reading of 0.0 volts right here. And then the rest will flow on our bulb, which is 5.3 volts because we have a total of 6 volts right here. So if you want to have an exact reading of 5 volts, then you must have a 5.7 volts voltage source on this one. Okay, but on the other hand, so we have 6 volts right here, and then as you guys can see, negative is connected to the positive, and then negative is connected to the positive. So with that, we are now forming a reverse bias. So up to this point, it's already, consuming the entire 6 volts. So we have a reading of 6 volts, and then on the bulb, okay, we have a reading of 0 volts because up to this point, it doesn't permit the flow of current anymore. Okay, so I hope we are now clearer when it comes to forward bias and then reverse bias. Okay, so let's have a continuation. So we also have this kind of scenario wherein we have partially forward bias. So let's just say that in here we only have 0.4 volts as your voltage source. So yes, if you don't have a diode, then that's already enough to lit up this LED. Okay, so even 1 volt is, I think, already enough. So though it is super dim, but since we have a diode right here wherein it requires a voltage of 0.7, it won't be able to pass through, or it won't be able to activate this diode right here. Okay, so as a reading, we only have 0 volts right here. So we call that one partially forward bias. Okay, so as you guys can see, the depletion region is still there. So if we still have depletion region, if we can still see it, then meaning it's not enough to pressure the negative side and the positive side to meet each other. Okay, and then if we have a 0.7 volts, so as you guys can see, the depletion region is fully collapsed, meaning the negative and then the positive can freely meet with each other. Then we now have the flow of current right here. Okay, so this is already a complete forward bias. All right, so that's actually it for this discussion. And then for this one, this is just a short quiz wherein you can also find that one here. So that is a short quiz. So this is most likely a bonus already because you can already answer this one just by searching on the internet, or just by going back to what I've discussed. Okay, so this is 1 to 4. So just check them out later on. And then here's the conclusion. So semiconductors are materials whose electrical properties lie between conductors and insulators, like for example, silicon and then germanium. So for the p-type, again, it has more holes on it, and then n-type, it has more electrons on it. And then diodes are electronic devices created by bringing together a p-type and an n-type material. Okay. And then here is the, again, the definition of forward bias. So it connects the positive. All right, sorry for that. So it connects the positive to the diode to the positive. So positive to positive and then negative to negative for the forward bias. And then for the reverse bias, so it's the other way around, positive to negative, and then negative to positive. Okay. So here's the depletion region of a forward bias. So it's narrower, and then reverse bias has a wider depletion region. Okay, so here are the characteristics of a diode. So diode always conducts in one direction. Okay, and then diodes always conducts current when forward bias or zero resistance. So we call this one zero resistance because kulit-kulit mo ah. Okay, sorry for that. That is my cat. Okay, so this one doesn't have a resistance. However, again, this one eats up a certain amount of voltage. So 0.7 for silicon and then 0.4 for germanium. And then diodes do not conduct when reverse bias. So it's like, having an infinite resistance because it doesn't allow the flow of current. Okay, so voltage across a forward and reverse bias. So it can be demonstrated through the use of solid state physics that the general characteristics of a semiconductor diode can be defined by the following equation for the forward and reverse bias regions. So this is the one that we are going to discuss next meeting. So the computation and how to compute the volume, the forward bias, reverse bias on this certain path. Okay, so that's it for the introduction of electronics. So any questions so far? Question or clarification?
No, sir.
None, sir.
None, sir.
Wala po.
Answer.
None, sir.
All right. So again, just a reminder, just answer this one before September 9th. Short quiz and then the case study number 1. Right. So if you guys don't have a question anymore, then let's just meet again later at exactly 11:30 for those who has the laboratory. Okay. So goodbye and thank you guys for coming. So I really appreciate it. I hope you guys.
Thank you din po, sir.
And I hope you guys will still attend, the following meetings. So,
Thank you, sir.
thank you too.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you too.